Welcome back. Today I will show you how to use functions to compute factorial of a number. We will see two different ways of computing factorial. First, we will see how to compute factorial using iterative mode, wherein we will use while loop to compute factorial. The second one will be using recursion. So first, in the main function, I've written two print statements. Here I want to print the factorial of 5 using the two different ways. First, we'll be using a loop to compute it. So we will call loop underscore factorial with 5. And second will be using recursion. So first, what's factorial of a number? Factorial of a number can be written using this mathematical statement, wherein factorial of n is equal to n times n minus 1 times n minus 2 times n minus 3 times so on and so forth times 3 times 2 times 1. So all integers less than n will be multiplied until n is equal to 1, and the result will be factorial of n. Now let's see how to compute this using a while loop. So here I'm declaring a function called loop underscore factorial. Its return type is an integer, and it takes one argument, which is the number of which we want to compute the factorial for. Now within the while loop, within the function, I'm declaring a variable called result. This holds the factorial. It's initialized with value equal to 1, and then within a while loop, I'm doing two things. First, I'm computing result times n, storing that in the result, and then decrementing n by 1. So first time when the loop is executed, in the first iteration, we will have 1 times n. So result will be equal to n will be equal to n minus 1. So in the second iteration, we will have result n is n minus 1, so the product is n times n minus 1. And so on and so forth until n is equal to 1. When n is equal to 0, this while loop exits and we will return the final result. Now let's run this program and compute what is factorial of 5 using loop underscore factorial. Now notice factorial of 5 is 5 times 4 times 3 times 2 times 1, which is equal to 120. And this also prints 120. So this is good. Now let's see how to modify this program and compute it using recursion. Now I can write factorial of n in a different way. Factorial of n is equal to n times factorial of n minus 1. This is a more mathematical way of defining factorial, wherein to compute factorial of n, we first need to compute factorial of n minus 1 and then multiply the result with n. Factorial of n minus 1 will be equal to factorial of n will be equal to n minus 1 times factorial of n minus 2, right? And so on and so forth until we reach factorial of 0, which is the base case, and factorial of 0 is equal to 1. Now we can implement the same structure using what's known as recursion, wherein we will compute factorial of n by computing factorial of n minus 1 first. So to do this, first we need to see what will be the result of the base case. Here we know the base case is when n is equal to 0 and the factorial will be equal to 1. So first we will write a condition which checks whether n is equal to 0. If it is equal to 0, we will simply return 1. Else if n is greater than 0, we will return n times factorial of n minus 1. And that's it. This computes the factorial of a number. Now notice how simple this piece of code is rather than the while loop. All that while loop did was to roll out this recursion process, wherein you can write factorial of n by replacing factorial of n minus 1 using this. And then you can replace factorial of n minus 2 with n minus 2 times factorial of n minus 3 and so on and so forth. And you will end up with the same expression as before. So both the iterative and the while loop computes the same thing. It's only a different way of doing things. In this short program, you won't notice that rewriting this with recursion actually has more benefits. But with more complicated things, like when you want to do like a breadth first search of a binary tree, using recursive functions are far more, writing recursive functions are far more simpler than writing out a rolled out loop. Now let's compile and run this program. And let's see what will be the factorial of 5 with loop underscore factorial and recursion. So like before, we saw factorial of 5 with loop underscore recursion is 120. Now let's continue the program and see what is factorial of 5 using recursion. Alright, now notice factorial of 5 with recursion is still 120. The advantage was that instead of computing factorial of n in a loop, we could solve smaller and smaller problems first and then use the results to compute the final result. So here first we solved factorial of 0, then we solved factorial of 1, then we computed factorial of 2, 3, 4, and used all of these intermediate results to compute factorial of 5. So in order to see how this is actually working, let's debug this program now. Let's see what will be the value of how will this function be called several times. So first n is equal to 5. Now let's continue. So we know n is not equal to 0, so it should go to the else if n is greater than 0. So let's see what happens when we continue. So notice the function is again called, it is calling itself, and this time n is equal to 4. Alright, so now let's again, n is not equal to 0, so it should go into the else if, and it will call itself again, this time n is equal to 3. The same thing repeats, so we will call the same function with n is equal to 2, same thing repeats, we will call it with n is equal to 1, and now we will call it with n is equal to 0. Now this time it is returning the value. So this is the base case. So it's important when you're writing recursive functions to think about the base case. If you don't have a base case, what happens is this can go into an infinite loop, into an infinite recursion. So similar to a loop, when you don't actually, so similar to a loop, there can be a possibility where the loop condition satisfies infinitely and the loop runs infinitely. Here the recursion can also go to an infinite state if we don't have a base case. So it's always important to think about a base case and to make sure that the base case is executing when the recursion is when the function is called recursively. So let's continue. Now notice the execution go back to the previous state. Now n is equal to 1, and we have the result of factorial of 0 multiplied to this. So when I continue, it goes back to the previous state where n is equal to 0. And this time factorial of n minus 1 will be multiplied with, factorial of 1 will be multiplied with 2. And the next time we will go back to where n was equal to 3. Next time when n was equal to 4. And finally when n was equal to 5. And this time we will return the actual factorial value at the end of this loop. So when we look at the print statement, we should see factorial of 5 again is equal to 120. So this ends the short video on recursion. We saw how to compute factorial of a number using both iterative and recursive function. In the recursive function, we called factorial of n several times by solving the smaller problems first, and then we used the solution of the smaller problems to build the solution of the bigger problem. We saw that recursive way of writing this program was shorter, more elegant, and it followed the mathematical structure more closely. So it's a good idea to use recursive functions whenever we can, but we should pay attention to the base case and make sure that the base case is evaluated to ensure that the recursive function exits without going into an infinite recursion. Thank you.